Hey guys, welcome back to the channel. So in this video I'm going to show you some welding tips which I use for my work. So this video is going to be a little longer than I usually do because there are a lot of stuff which I'm going to cover up in this video. So hopefully I'm able to teach you something and you will improvise that in your work. So I divided this video in multiple parts, so if you want to jump over certain duration then you can follow this image for that. So here are all the tools which you require for starting a welding work. So to prepare your surface and remove the slag from the welding, you need a wire brush, a wire wheel and a chipping hammer. After that we have speed square and combination square for marking straight lines and lines at various angles. Other than that I also have a correction pen. Other than that you can go with welding helmet and welding goggle. Here I have welding clamps which I use to hold down my workpiece, and you can make a bar clamp if you want to. There is a video on the upper right corner, you can check that. And here I have different types of grinding and cutting wheel, and you to hold your mild steel pieces to its place during the welding you can use these welding magnets. They came in various sizes and shapes, and the one I am using have an angle of 45° and 90° angle. So yeah, definitely grab some of them, it will ease your work. And this is my old trusty welding set. Also grab a pair of good quality welding gloves. So yeah, that's pretty much all you need to start a welding. So now jump to the second section. In stick welding there are a lot of different kinds of welding electrode which you can use, and few of them I'm going to cover up in this video, although there are few electrodes still left which I didn't find because people rarely use them. Here it's not difficult to work with non-ferrous material, but they definitely behave different as compared to ferrous materials, so definitely need some serious experience in that field. So here I have 6013 welding electrode with few mild steel filler rod which you generally use in TIG welding. So if you take a look onto your welding electrode, then you will find a number written on that, and that number has some meaning to it. The first two digits represent the tensile strength of that electrode, the third digit represent the position in which position it's easy to work with, and the fourth digit represents the coating and current type. And here the DCEP means direct current electrode positive and DCEN means direct current electrode negative. The next electrode we have a stainless steel electrode, and the digit written onto it is completely different from which we see earlier. Here that digit represents the grade of that material, and usually there is a L or H written behind that digit which represent the carbon content. Along with that I have stainless steel filler rod from TIG welding, and I am going to use them as a filler material for covering up my blowholes. So the next electrode we have a cast iron electrode, and it's come in two different types, machinable and non-machinable, and it's definitely not easy to work with cast iron because you need to preheat your base metal. I don't have right equipment to do that, so I never succeeded in that and always ended up with small cracks onto my weld joint. So if you want to fix hard surface material like gears and shaft, then you can use this carbon steel electrode, and it actually provide a hard coating once you have finished your welding. So if you want a hardened edge over mild steel, then you can just simply weld at the edge and you are ready to go with a hardened surface. Usually the hardness this electrode varies from 55 to 60 HRC. It's easy to work with this electrode. It's quite similar to the stainless steel electrode. The last one I have a aluminum electrode, and there are the copper and brass electrodes still left behind because I didn't find them, but they definitely cost way too much as compared to your regular electrode like mild steel and stainless steel. So if you want to improve your welding work, then you definitely have some control over your flow, and here are a few things by which how I start learning the welding. Although there are different kinds of flow in the welding, but I mostly use three of them. for my work. The first one I call the spiral motion, in which the material has been deposited onto the surface by a spiral motion. The second one is called the zigzag motion. It's similar to a letter Z. And the third one is forward and backward motion. And the difference between three of them is that the forward and backward motion gives you much thinner welding beads, and it approximately equals to the twice of your welding electrode diameter. So the first thing, you need to have a plate. It's good to have a larger surface, 8 inches by 8 inches in dimension, so that it's easy for you to consume a full electrode in one go. The first thing you need to do is draw some straight lines, and try to draw them with the help of correction pen, because it will not wipe off due to the overheat and still visible you. So the first technique I'm going to use is forward and backward motion, and I try my best to follow that line, kept my welding bead as straight as possible. And during the welding, you will see that how I use my left hand to provide a support to the welding electrode, so that I am able to follow that straight line. That's why I recommend to use a heavy duty welding glove, because that electrode heats up much faster during the welding process, and your left hand provide much better control over the electrode. I didn't go in a full pass, but I suggest you that if you are in a learning stage, then try to consume that electrode in one pass, and that will help you to maintain that arc continuously and will improve your weld bead. And during the welding, try to make yourself comfortable first, because only then you are able to achieve that result. So the next technique I'm going to use is a zigzag method. So the weld material is going to be deposited onto a larger surface area, and that's the advantage of using a zigzag or spiral method, and you are able to cover up twice the area as compared to forward and backward motion. So there is a deviation in the straightness, but try to hone this technique and try to get as straight as possible. Go from, and by measuring them, you can see the difference between the width of both the different techniques. The spiral method is also similar to the zigzag method, but only difference is the motion of your hand. But other than that, you are able to achieve the same result and same bead as the zigzag motion. So try to go in all the different direction, from forward to backward, backward to forward, and left to right, right to left. Try to improve as much as you can, and make sure to try to do them with mild steel electrode, because they are very cheap. And the fourth and fifth technique is the one which I don't think anyone going to tell you, because they are used very rarely. But if you have no other to go, then and you have to do that work with the stick welding, then definitely hone those technique as well. So the fourth method is a fast drag method, in which you have to drag the welding electrode at a faster rate, but make sure to maintain your arc, and also make sure to have a thick welding bead, so that you are able to cover up your joint. And this process mostly used for thin pipes, because if you kept your electrode for a long time, then you are ended up with a blowhole. So I don't often use this technique, mostly because I prefer stitch welding technique, but I think it's good to give it a shot. Other than that, you can also play with zigzag and spiral motion by doing them in a faster speed. That will sometime also helpful, and in upcoming portion I'm going to show you all of these techniques. So last but not the least, my most favorite technique which I use to weld the stainless steel is stitch welding technique, and in that I proceed step by step and allow my previous weld to completely cool down, and then ignite the spark over that bead, and then coming forward towards myself. And if you compare fast drag method with stitch welding, then I would say that the stitch welding gives you much better result, because it heats up the base metal and made a good fusion with the filler materials. But for the welding, the only thing I recommend you is that try to give yourself some problems and try to proceed in each and every side direction, or so that you can hone your technique. In my early days, I tried to write some letters with stick welding that also teach me about the direction of flow. So definitely I would recommend you to do these kinds of techniques and repeat them again and again until it seems that you master the welding technique. And also try to play with different feeds and speed settings to find out which setting works best for you. So in stainless steel welding there are few joints which I think some of you will know and some of you don't, so I decided to share them. So the first joint is that in which I am going to use the one side of the pipe to cover up the open end of the second pipe, and here you can see that I marked 3 surfaces and leaving one as it is. And now I'm going to cut all the 3 sides which I have shaded. And once the piece has been cut down, here you can see that how this joint formed, and it's easy to do and don't require too much work to do, so definitely give it a try. For the next joint I'm going to use this piece and weld it at the open end so that I am able to get a closed compartment. And for this you just need to simple butt weld 2 pipes, and then at the open side you can weld this piece. Sometime you have to weld pieces at an angle greater than 90 degrees, so for those cases you can follow this technique. So if you have to make an angle of 140 degree, then usually you make an angle of 70 degree onto both the pieces, and then by joining them together you are able to get that angle. But in this case I'm going to use this protector and clamp those pieces over one another and make sure that they have followed that angle, and after that I trace the outline and transfer it onto the back side. And if you want to know much about this technique, you can watch my previous video. There is a link in the description section about that. Once all the joint has been prepared, I'm going to clamp them and make a tack weld first on both sides. After that I'm going to make a full weld. So I am not going to finishes up all the welding joints because I want to show you how these joints actually look like when you do nothing over them, and that will make a good comparison among all of them. So the first technique I use is a stitch welding technique, and I mostly use this and get a good result by using this technique. The next one is the zigzag motion, but I'm going to do that in a fast speed, and you will see that I'm going to focus onto that closed side as compared to that open end, because that will ended up in a blowhole. So most of the time I focus onto that closed portion of the pipe. The weld definitely seems good, but there is a small blowhole left, but it's definitely not difficult to fix. The next technique is a fast dragging method, and again I try to keep myself in between the joint so that I am able to fuse both the sides together. Sometimes this technique not works well for me, so I try to avoid this method and always stick to my stitch welding technique. There is a slight cavity left in between here, so this technique is called a filler rod technique, and in this technique you have to use another piece of welding electrode and place it onto that joint and then strike the arc. To make a good fusion with the base metal and the filler metal, you need to slightly increase the ampere. In my case I increase it about 70 amps. If you normally do that with without the filler rod, then that will always end ended up in a blowhole, but in this case the filler rod actually increase the thickness of your surface, so it will not going to create any blowhole. So if you have a blowhole like this, then the right way to fix that is to proceed from outside and then ended up in inside. And for that I am going to use the another piece of filler rod, and I'm going to place it inside that hole and then strike the arc, and that arc is strike in between the rod and the surface, so that will fuse both the pieces together. And then I follow up that perimeter and come to the inside. So whenever you are proceeding for a next wave, then try to clean up your welding joint. So now it seems that the welding has been finished and the hole has been completely filled, but it's not the way it looks. Once the grinding has been done, you will see a hole in between that, but it's not that large, and you can easily able to cover it with the same filler rod technique and ended up closing that big hole. So once the welding has been finished, I'm going to clean up all the joints with the help of pickling agent, and after that I will show you how these joints actually look like. If you want to know much about that pickling agent, then you can watch my previous video. The link is in the description section, and there is a card on the upper right corner. So the first joint I got over here is with the help of stitch welding technique, and you can see that there is no blowhole inside that joint. The second one is achieved by zigzag method at a faster speed. There is a very tiny hole left behind, but it's not difficult to fix that. To this side I use two different techniques, stitch welding and filler rod technique. There are few spots left, and that is because sometimes slag came over there and not able to deposit the welded material into that joint, and another reason is also due to the low ampere. Then here we have a giant hole which we fixed earlier with the help of this filler rod, and it seems to be quite promising. And after that we have a fast drag method. Here you can see there is a small cavity left behind, which I think again not difficult to fix at all. So on to the finishing, I didn't pay much attention because that wasn't the motive of this video. I already did this in my previous video. If you want to know much about those finishing process, you can follow that video for that. use this electrode to do that. And here I am going to demonstrate you with this plate. I have tool steel plate. It's belong to D3 category. I already prepared the material for the welding. The current setting I am going to use is around 110 amps, and this electrode is almost similar to the stainless steel electrode and gives a nice weld bead. So other than that, you can use it to make a hardened edge over any mild steel and use that edge as a cutting surface, like which I am showing here. And once the weld bead has been cooled down, it provides you a hard finish, and you can check that hardness with the file. It's not hard as the hardness of file, but definitely provide you an cutting edge. So now I'm going to use cast iron electrode to fix that broken jaw of my bench vise. In my past, I didn't able to recover this because I was ended up with bunch of crack on my weld bead. So I decided to make a new one from scratch. The problem with cast iron is that you need to heat up the surface so that your filler metal can be fused with your base metal, and I didn't have an oxyacetylene torch so that I am able to reach up to that temperature. And other than that, the material thickness is way too much, and when I try to heat up that surface with the torch, it cools down rapidly and ended up with the cracks on the weld joint. So that's why I never succeeded in welding a cast iron. But I think if you pay much attention onto the preparation then and use a oxy torch to heat up the metal, then definitely it's going to fix that problem. So the last electrode I'm going to show you is the aluminum electrode, and I made the bevel first and prepared it for welding. I used this electrode once a time, and this is the second attempt. And so the problem with aluminum electrode is that it burns out a quite fast speed, so you have to compensate that. And in my case, my hand is set according to the stainless steel or mild steel electrode, so I need time to set my hand onto the aluminum electrode. But once I get my hand set, you can see that the welding bead is looking pretty decent. Definitely not the good as needed for a welding, but it's much better than my first attempt. But in the end, I would say only one thing is that if you want to improve your welding, just keep doing practice and practice, because that's the only shortcut method to become best in welding. And try to give yourself some problem and then solve them. So in the end, if you like this video and learn something from my experience, then definitely give this video a thumbs up. And if you didn't subscribe to the channel, then make sure to subscribe as well, and also visit the channel page to watch more stuff. Till then, have a great day.